So why we care? What is so special about matrix? Matrix is a collection of vectors, and one vector is one variable. But for the data analysis, we typically need many of those variables, right? So if you collect many variables, you have one matrix. So one data set is actually given as a matrix. So that's why it's important. So how do you make it? So this is just an example. So please type this. So now I create a vector, x, right? It's number from 1 to 12. So how to get a matrix out of this? There are many different ways, okay? One way is manipulate the dimension. Dimension of x right now is, it's a vector. So we typically says it is 12 by 1 vector. That's the dimension of x right now. So you can change it, okay? So how do you change it? Type. Now dimension of x gets as an example 3 and 4. Now you have a matrix. So what does it mean? Now I just change it to 3 by 4. What is this? It's so annoying. So basically it has 3 rows, so that's the meaning of 3, and 4 columns, okay? Number of rows and number of columns. So you can change it. For example, if you say dimension of x gets 6 by 2, then you have a 6 by 2 matrix. 6 rows, 2 columns. So it's like you have 6 individuals in your data set, person 1 to person 6, and you have 2 variables. Okay? So this is the first way, method 1. The second way, maybe a kind of more straightforward way, is to use a function matrix. So it has a few inputs that you have to type inside. One is that you have to type all the numbers that you're going to fill the matrix. So for example, I like to use these words, these numbers, 1 to 12. Now you have to tell what is the number of rows and number of columns, right? But you have 12 numbers, so we just need 1, not 2. Because if the number of rows is, for example, 4, the number of columns must be 3, right? So let's do that. N row means number of rows. If you say that, that's 4, then you have a matrix, right? So this is the number I'm going to use, 1 to 12. I specify that the number of rows must be equal to 4. So 4 people in the data set, which kind of automatically says the number of columns must be 3. So if the number of rows is 6, then you have a different matrix. Now one thing is that when we fill the matrix, we do one particular way. So I use the number from 1 to 12, but the way I fill this matrix is by column, right? So 1, 2, 3, 4, I fill the first column first. And then I move the next column, fill it up, and move to the third one, right? So the matrix is filled by column. If you want it in a different way, you can change it. if you say that buy low is true, T means true, then you can feed it up in a different way, right? So I feed it up by lows. First low, and I move to second low, things like that. So do you get the idea? Some matrices are easier than others. So for example, so if I say DIAG 1 to 3, so let's make it 1 to 4. What do I have? So I have a diagonal matrix, which is basically 0 everywhere else, and the diagonal term use these numbers. Okay, so if that's what you need, you can make it pretty simple. So you don't have to type all 16 numbers by using this. Now suppose that this is my X. So X is a 4 by 3 matrix. How to transpose this matrix? That's T. Okay? Transpose means you change rows and columns. Get a new matrix. So this is a second method. So the first method is to change the dimension of a vector or a matrix. The second method is use this function matrix, right? Now there is another way, the third way, which is very convenient. So let me, but to show this, we have to retype the weight and height. Can you do that? Can you retype the data? So we have weight and height. So weight is one variable, height is a second variable. So we have two vectors, right? So I can simply combine them to make a matrix or a data set. So how do I do that? C bind. So bind means put things together. C means columnize. So I use one variable in the first column, use a second variable for the second column. So this is another way to make a matrix. Suppose if you have three variables, you can use C bind, you put them together, make a matrix, okay? So can you stack the vectors or put the vectors together in a low ways? The other way, you can use R bind. If this is what you want, right? So weight goes to the first row and height goes to the second row. But this is not a typical way, right? A column means a variable. So to get what you want, one way is to transpose it back. You can use T. So that's how you make a matrix. Now once you have a matrix, we can do a lot of interesting things. So the next topic is indexing. So what do I mean by that? This is the first row of the matrix X, and this is the second column of the matrix X. So that's how we call columns and rows, right? If you want to call this particular number, the index of this number in this matrix is third row and third column. That's how you're going to call it. So if you say x 3 and 3, then we just call this particular element of x. So what is the number in the matrix X, which is in the third column and third row? That's 9. Okay? What's the number in fourth row and first column? That's 10. Now, can you call the entire row, like second row? So you can do this way, okay? So what I mean is, I like to have second row, but I want everything in terms of column, okay? So second row and everything in columns. So that's the meaning of empty space. What about the second column then? Third column. Okay? So I want everything in rows, but column-wise I want only 3. Okay? That's what I want. What if you want the first and second rows? Can you guess? So how do you call the collection of first and second rows? You need 1 and 2, right? In the first place. So this is one way, or this is the second way. Now can you try everything in the third column and the first column? Can you try that? Can you make it that order? Third column and the first column. Third and first. So I want to choose this column, and then I want to choose this column. Okay, and I want them together as a smaller matrix. Okay, let me show you something that is actually quite interesting. So again, this is a small data set. We have person number 1 to 5, and we have 2 variables, right? Now I like to select some individuals who satisfy certain conditions. Now for this, it's very easy. You can just take a look and you can just select it, right? Suppose that you have 500,000 people in your data set, and how are you going to do it? With bare eye. So we need something more, right? One easy way is to use indexing. So what do I mean by this? So suppose that I like to see the weight of persons whose height is greater than 1.7. Okay? Suppose that that's my condition. So whoever taller than 1.7 meter, I like to see their weight. So how do I do that? It's like I'm asking a question to R. Whose height is strictly bigger than 1.7? You can ask it. Try it. What do you get? And you have a very straightforward answer. False means the first person, the condition is not met. It's not true. The second person, the condition is met. It's true. Third, it is true. Fourth, it is not. Fifth, it is true. Okay? So we have a lot of zeros and ones. I can use it as an index, and I put weight. So these are the weights of persons whose height is bigger than 1.7. You can check it. No. Sorry. So what's the idea? The second person, the height is bigger than 1.7, so we get his weight. The third person, we get his weight. And the last person, we get his weight. Okay? So what happened? So when you type this, are interpreted in such a way that I, the person who entered this comment, like to see the weight only when the conditions are met, only when the answer is true. Okay, so whenever the answer is true, it shows the result. The answer is false, it doesn't show the result. Is it clear? Now what if I like to see weight and height of any persons whose height is bigger than 1.7. So how do I do that? So I get the matrix and then I put the condition. Okay? Type it, please. So do you get the idea? So these three people satisfy that condition. Now let me use this matrix X. And I like to give you a quiz. Okay, select every individuals. When I say individual, just by convention, I mean lows. Because by convention, low means people, schools, companies, whatever. The unit of data, column means variables. So I like to select every lows when the third column is bigger than 10. The value of the third column bigger than 10 is a condition. If the condition is satisfied, select entire low. Can you write it? So the condition is this. The third column should be bigger than 10. That's a condition. Use this condition and select every lows whose third column is bigger than 10. Okay. So we can have one condition. Can you have more than one condition? Yes, you can. So suppose that the condition is the height is between 1.65 and 1.75. So it's a combination of two conditions, right? Bigger than 1.65 and less than 1.75. So how do you do that? So that's one condition. So there's another condition. And you can combine them by using AND. Okay? So the first person's height is 1.7, so it satisfies. It's bigger than 1.65 and less than 1.75, right? It's in between. So we choose him. True. Doesn't satisfy, doesn't satisfy, doesn't satisfy. It's at the cutoff. But the last person, his height is 1.74, so it satisfies both conditions. Okay? Now, so that's how you use AND, A and B. It's like you have one condition and B. So in R, this means and B. So can you combine things in a different way? What if A or B? So suppose that the height is less than 1.7. So if your height is less than 1.7, that's okay. Or if your height is bigger than 1.8, that's also okay. Okay. So that's how you express or. In R. So you can mix these conditions. So why do you need this? Now suppose that you have three variables. The first one is wages. The second one is education. And the third one is, for example, age. So then you can mix some conditions, right? So I like to see the wages of people who have more than 14 years of education and at the same time whose age is bigger than 55. That's how you mix conditions. And then you can select only those people who satisfy those conditions. Okay? And that's how you do it. Okay, so that's our brief review. Not a review, actually introduction to R. So from now on, we are going to have an hour session, not this long, but maybe 30 minutes per week sometimes. Okay? So for this, please review this lecture note and make sure that you buy at least one textbook, our book, so that you have a reference at home, you read it and you follow it, then pretty soon you'll be very comfortable. It is actually not that hard to learn these things. Okay, do you have any questions? General questions? Anything? Oh, so that's a good question. So the thing is that, can you check it? So without the period. So I hope that this is something you figure out. So the question is, what happens if there's no comma here? So in this example, you produce the same answer, right? I just want to be more specific.
아까 그 히바인드로 하신 그걸로 해서 안 하면은 1년로 나오더라고요. 아, 1자로.
Right. So here, what I try to do is to match the dimension. So this question is 4x1 kind of question, right? To match the dimension, it's kind of logical to put it in this way, because you have 4 rows, 3 columns. So we just happen to be lucky in this example, but if the dimension is not well matched, then R can get confused. Okay, do you have any other questions? Oh, so where do you find it? Okay, so it's here, right below backspace. Okay, so you push Shift and this 1. It's this key, right below the backspace. Okay, anything else? No? Now, the next topic is chapter 2. Review of probability. So did you print out the lecture notes? Do you have your copy? Can you show me? Okay, so before you come, make sure that you have a copy of the lecture notes, okay? If not, maybe I think that you can just send it to the printer right there. You should be able to make a copy pretty easily. Okay, it says 9 things you have to know about probability. So what is the 9 things that I expect you to know for this class? By the way, everything in here was covered in your probability, the statistics class. So I'm pretty sure that you took it as a freshman. So I'm not going to go to details. I just like to remind you of a few definitions, just point out a few tricky things here and there, and then I'm going to give you a homework so that you can remind yourself by solving the homework, okay? So that's the idea. Okay, so what is the first thing you have to know about probability? So it says the probability is the first thing you have to know. So what does it mean? So in your statistics class, you learned the meaning of, for example, random experiment, sample space, event, and then you learned the definition of the probability. Do you remember them? So if not, you can read the textbook, page 14 and 15. So it has a few reminders. So in the textbook, it has 3 examples of a random experiment. The first example is you have a fair coin, you have a coin, and you toss it. Okay? So why this is a random experiment? Anybody who want to explain? So why we call it a random experiment? A random experiment must satisfy 2 conditions. Condition number 1, it should be unpredictable before you throw it. Okay? After you throw it, you should be able to determine the outcome. So the outcome is not predictable before you toss, but after you toss, you must know the outcome for sure. There shouldn't be any uncertainty left. Okay, so that's the definition. The key is the timing. So why this matters? Because we like to define probability on a random experiment. If something is not a random experiment, defining probability makes usually no sense. It leads to a lot of inconsistency. Okay, so unexpected things. So is it a random experiment? Can you explain? And the timing is the key. Before you throw a coin, can you predict the outcome? So when I say predict the outcome, it means you know the outcome. It's not like that with 50% probability, it's going to be something like that. It's not a prediction. So the word prediction here means you basically know the outcome for sure. So throwing a coin, before you throw it, do you know the outcome? No, right? So that's the first condition. Now, after you throw it, do you know the outcome? So it's a random experiment. You satisfy two conditions. Now you have a dice. You throw it. Is it a random experiment? Before you throw it, do you know the outcome? No. After you throw it, do you know the outcome? Yes. So it's a random experiment. Now this is not just a good example, but some old timer like me, it really happened. Right now the computers are very stable, so it never happened. But when I was at college, it really made a good excuse. The computer just crashed last night, so why I couldn't do my homework, things like that. So computer crash while working on a final project. Is it a random experiment? So before you finish it, you never know, right? But once you finish your project, do you know the outcome? So it's a random experiment. So we define probability on a random experiment. If something is not a random experiment, it's better not to think about probability. So what is sample space in your statistics? The definition was a list of all possible outcomes of the experiment. So in the first experiment, you have a coin, you throw it. It says a list of all possible outcomes, right? So that's a sample space. So you either have a head or a tail. That's a sample space. And you have a dice. You have 6 dots, right? 1 dot, 2 dots, things like that. So sample space means 1 to 6. Number of computer crashes can be 0. It can be 1. It can be more than 1. So this is sample space of your third example. Does it make sense? Okay, event. Again, in the statistics, the definition was a collection of outcomes. Any collection of outcomes in the sample space makes an event. But it's better be organized, right? If it's not organized, it hardly makes any sense, not useful. So usually one way to make an event is to give a condition. Like you throw a coin and head shows up. Then anything that satisfies this condition is in the event, like H is in the event. T is not, right? T does not satisfy this. T is outside. So this event A just has H as an element. And the second example, an event can be defined in this way. You throw a dice and you have an odd number, 1 or 3 or 5. So it defines an event. Or you have a number that is strictly less than 4. So your event has 3 numbers, 1 to 3. 4 does not satisfy this condition, right? So 4 doesn't belong here. In the last example, no crash makes an event because you know that 0 is in, but 1 is not, right? So anything that classifies all the outcomes makes an event. So you probably remember this. A sample space is the whole thing. It has a lot of outcomes in there, right? The whole space, whole set. An event makes a boundary, something like that. So what does it do? You basically says that some outcomes is in and the other outcome is out. Okay, in that sense, it just set the boundary. That's an event. Now, what is the probability? So that's our goal. The definition is actually very simple, intuitive. It says a probability is a non-negative number assigned to each outcome. So that's that. So you basically, so the rule is you have to assign a non-negative number to each outcome. Okay, that's the rule. But some normalization is necessary. Otherwise, you want to compare which one has a bigger probability, meaning bigger number. But we like to make sure that a unit makes sense. What I mean is, if 10,000 is not, what am I going to say? I get lost. Sorry, I'm a little bit sick. So sometimes I just get lost. So what we want is that when we say like the probability being 0.6, we like to have some kind of intuitive sense of what it means, right? So in that sense, it's better to normalize those numbers. So one method is we just agree to say that the sum of all probabilities is equal to 1. It's one normalization. So that we know that 0.1 is kind of smaller probability, but 0.5 is bigger, and 0.99 is pretty big, almost certain. Okay, so that's just two conditions. So let's go back to example 1. In the sample space, we have H and T as two potential outcomes. So the probability is just a number assigned to each outcome. You wanna assign a positive number and a positive number here, and sum of two positive numbers must be equal to 1. So that's an agreement, that's a definition. So what kind of number you wanna assign? Can I give 0.3 and 0.7? Is it okay? It seems okay, right? Non-negative numbers sum to 1. So what's the problem? The problem is that if you go back to the definition, you will find that it's not any coin. It's a fair coin. Okay? So what numbers you wanna assign on these two outcomes? What's the meaning of being fair? Fair means nobody cheats. You throw a coin. So what is the probability of having a hat if you throw a fair coin? That's 0.5, right? So these two numbers satisfy everything. Non-negative numbers, every outcome gets at least one number. Actually, only one number. Some of those numbers are 1. And we even satisfy that those coins are fair. Okay? So that's why we believe that if you throw a fair coin, the probability of having a hat is equal to 0.5. So that's why we have that kind of intuitive sense. Does it make sense? So that's how we determine probabilities. It's very simple, right? Okay, example 2. The sample space has these 6 numbers, and you like to define probability on these 6 numbers. So you have assigned 6 different numbers, 6 equal or different numbers to these 6 outcomes, right? Some of those numbers must be equal to 1. Again, it's a fair dice, a balanced dice. So one number you want to assign. .1, 0.15. So we need 6 numbers, probabilities. Any idea? It's a balanced dice, right? So probability must be equal, sum to 1. So the only reasonable choice seems to be 1/6. Non-negative numbers, every outcome gets one number. They sum to 1, and they're equal, meaning that it's fair. Okay? So that's how we determine a probability. So that's how we assign probabilities on one outcome. How to assign a probability on an event. So each outcome in this event, 1, 3, and 5, individually has this much probability. And the probability on the event must be the sum of these 3 numbers. Okay? 1/2. Why? Because if you throw a dice, you either have 1 or 2 or 3 4 or 5 or 6. You never have 1 and 3 at the same time, right? So in that sense, they're exclusive to each other. So the probability on an event is simply the sum of the probability on the outcomes that belong to this event. So that's why you believe that if you throw a dice, you have 50% chance that you have an odd number. Right? Okay, if you want to know more, please read those textbooks, or you can read the textbook that you use in statistics. Now the random variable. So what is a random variable? This is a definition. A random variable is a map that assigns a number to each outcome of an experiment. So you have a list of every outcome in an experiment, and you can assign a number to that outcome. That's a random variable. This is one example. Again, random variable can be given as a condition. So in the first example, suppose that you define a random variable, the number of heads. Okay? So this is the definition of the random variable. Suppose that you throw a coin and you get H. What is the number of heads? 1. So it assigns this X, random variable X assigns 1 to this outcome. Suppose that you have T. How many heads do you have? 0. So it assigns 0 to this outcome. So this is a random variable. The second example, you can toss 2 coins. You toss 2 fair coins. So the potential outcomes of this random experiment is these, right? You have 4 potential outcomes. You can define a random variable such as the number of heads, this example. Now suppose that you throw 2 coins and you have H and H, head and head. So what number do you have? What number this random variable assign to this event, to this outcome? You assign 2, right? There are 2 heads. How about HT? You assign 1. Things like that. So random variable assign a number to each outcome. So why we want to do that? It's simply because when you have numbers, you can easily manipulate them. You can add them, you can divide them, you can subtract them. It's harder to manipulate things like TT or HH. So we like to make things more convenient. So that's the second thing that you have to know about probability. There's a third thing, the probability distribution. So what is the probability distribution? So it says that for this topic, I want you to know the meaning of joint distribution, marginal distribution, and conditional distribution. Do you remember what makes things a probability distribution? So basically, a probability distribution in an easy, simple case is given as a table, right? A table is a probability distribution. You need 2 things. The first one is the value of the random variable. So this random variable can take 0, 1, or 2. It's number of heads when you throw two coins. And then in the second column, you need probabilities of each number, each case of the random variable. So what is the probability that you have no heads when you throw 2 coins? That's 1 over 4, right? 1 over 2 times 1 over 2. What is the probability that you have 1 head when you throw 2 coins? That's 0.5. 2 gets 0.25. So when you have these 2 things, you have a distribution. The value of the random variable and its probabilities. Now, what is a joint probability distribution? Sometimes you have more than 1 random variable. Sometimes you can have 2 random variables. Again, the example is the first random variable is people's wages. The second random variable is their age. Okay? So why are they random? Because you never know who I'm going to choose. I have 50 students. Before I choose, I do not know who I'm going to choose, right? And after I choose one person, then everybody knows. So if I ask his or her wage and age, then we can have a two random variable. Realization of two random variables, right? So that's a joint distribution. If you have all the probabilities of every possible values of wages and age, then we have a joint probability. So we have an example here. So can you take a look at example 1 in the second page? Can you read it? So here's an example. I have two random variables. One random variable is the weather. Okay? So I just call it X. It has two possible states or two possible outcomes. It's either raining or sunny. So when it rains, I assign 0 because a random variable assign a number to an outcome, right? And if it's sunny outside, I assign 1. And I'm interested in my commuting time, how long it takes. Suppose I drive. I drive to school. Or suppose that you do that. So my Y is commuting time. Again, it only has two states, two outcomes. It's either a short commute, like 30 minutes, or very long commute, 1.5 hours. So when it's short, I give 1, 0. Long, I give 1. Okay? Let me ask you this. Are they random variables? Otherwise, we shouldn't define any probability. What do you think? Is the weather a random variable? So weather today can be random variable because, again, the key is the timing, right? Before today, so suppose that I leave home at 7 o'clock. Suppose that that's the case. Before 7 o'clock of this morning, was it exactly predictable? Nobody knows, right? Actually, that's one of the reasons why I'm kind of sick today. I couldn't predict the weather today and yesterday. But after today, is it predictable? Do you know the outcome? Sunny or rainy? We know the outcome, right? So it's a random variable. So you can define probability. How about commuting time? Is it a random variable? Yes, right? Now, what's the meaning of these numbers? So 1.15, 15% means the probability that I had a short commute in a raining day. 0.07, 7% means I had short commute on a sunny day. 0.15 means I had a long commute on rainy day. Things like that. Okay? It's more like a frequency from the past experience. So your experience or data gives these numbers. So by writing down your commuting times every day in the past year or past 2 years, you can generate these frequencies. And they are called a joint distribution. Okay? Because you simply count the number of days that you have a long and short commute on either case of the weather. Right? So as a rule of thumb, it's kind of good to remember that a data set provides a joint distribution. You just summarize your data, then you have a joint distribution. So as a notation, we can say, what is the probability that I have a short commute, comma means and, on a rainy day? So that's 15%. So that's a joint probability. So it's another way to say a comma means and, okay, inside of the probability. So that's joint. So we have two random variables, and you like to know what happened to x and y at the same time. Now what's the marginal probability? So sometimes you say, what is the probability I have a long commute on a sunny day, right? If that's what you want to know. What if you just want to know what's the probability that I have a long commute? Okay, so in this question, we simply ignore whatever happens to the weather. It can be sunny, it can be rainy. I don't care. The only thing I care is whether I have a long commute. Okay, so that's marginal distribution. So what I mean is, I only care about y, but whatever happened to x, I don't care. Okay, that's an example of a marginal distribution. Okay, so take a look at part A, the two examples of joint probabilities. So what is the meaning of the first probability? X takes 0 and y takes 0. So you can answer it in Korean. It's okay. I'll interpret it. So what's the meaning of this joint probability? Anybody who want to try? Can you try? Sorry. So he says it's the probability that it's raining, but you have a short commute. Do you agree? How about the second one? The probability of x gets 0 and y gets 1. So it's a probability that I have a long commute on a rainy day. Okay. So how about B, marginal probability? What's the meaning of probability y takes 1? So it's a probability I have a long commute. And in this statement, it's okay to be the sunny day or the rainy day. It really doesn't matter. Okay? Now that implies one thing which is very important. How to find out a marginal probability. So in the marginal probability, you grab this number because you have a long commute. And you also have to grab this number because you still have a long commute, right? So if I have to write it, So as long as y is equal to 1, no matter what happened to x, I like to add them up, right? So that's how you get the marginal probability. Because we don't care about x. So that's the rule. In your statistics, we get the marginal probability by summing the numbers, row-wise and column-wise. So the marginal probability of y equal to 1 was a sum in this direction. Do you remember that? That's how you did it. So 7, 8. So that is the marginal probability. So how do you get the marginal probability again? You sum up joint probabilities. Now, what's really important is the conditional probability. This class is all about conditional probability. So the example is probability of y gets 1 given that x is equal to 0. What does it mean? So that's one example of a conditional probability. So when we interpret it, we go from the back to the front. Okay? So remember that. Given that x is equal to 0, given that I know that it's raining outside, what is the probability that I have a long commute? So that's the meaning of conditional probability. Okay? Now the important thing is that you have to know that this is not equal to they are different things. Can you see it? Do you understand? So let me repeat. This is a probability that it's raining outside and I have a long commute. It's a joint. Now this is a probability that I know that it's raining. And then you ask, what's my chance of having a long commute? I suffer the traffic jam. Okay? So again, important thing is the timing. And suppose I leave my home at 7 a.m. So joint probability is a kind of question you ask at 6 a.m. This is before you leave. You just got up and you ask, what is the chance that it's raining outside and you haven't opened the window yet? Okay? So weather is uncertain, unpredictable at this moment. You don't know anything about the weather. And you ask, what is the chance that it's raining and I will have a long commute? So that's joint. This is a probability that x is determined, revealed. So this is the kind of question you ask at 7:15. You already left. You know the weather, it's raining, okay? And you're driving. But long or short commute is uncertain still because you're not at school yet. Right? So there's no uncertainty here. There's a lot of uncertainty. So that's a conditional. Okay? So we are asking a very different questions here. Now why a conditional probability is important? It's because the question we ask as an economist, as a scientist, is given by a conditional probability. Given that, I know that this person has a college degree, an econ major, a male, 25 years old, and has this much experience. How much do I expect that he will make? Okay? So usually the question we ask is a conditional thing. Conditional probability, conditional mean, conditional variance, things like that. That's why conditional is important. So the thing is, when you analyze data, again, you collect data, right? When you summarize your data, you have a joint probability, bunch of joint things. And then you start to analyze it. You start to make summaries of this and that. What it means is you produce a lot of marginal probabilities. And the final stage is produce the conditional probabilities. And hopefully, you find the answer you want. Okay? So that's the procedure. By the way, how do you get the conditional? Do you remember? How do you calculate the conditional probabilities? So the formula is conditionally is margin, joint divided by marginal. Okay, remember that, joint divided by marginal. So joint conditional is joint divided by marginal. So what is the joint probability of y gets 1 and x gets 0? 0.15? Yeah? So 0.15. Now what's the marginal probability that x takes 0? So sum of these, right? 0.3. So the answer is 0.5. So 50% of chance. So that's the probability you have a long commute if you know it's raining. Okay, do you have any questions so far? Sorry. Okay, so that's the topic number 3. The topic number 4 that I want you to know is how to calculate the mean and variance. Okay? So let's see. So just as a reminder, the mean of a random variable x is sum of the value of the random variable and its probability. So you need 2 things, right? So this is the first line in your distribution. This is the second line in your distribution. You multiply them one by one for each person and you sum them up. So that's the expected value. What is the variance? The variance is you take the value of the random variable and you subtract the mean, okay? And you square them, and then you multiply the probability, and then you sum them, okay? So that's the variance. So mean shows you the long run average. So what's the meaning of this? So it's like, suppose that I like to know the mean of the height for this class. How do I find out? It's actually pretty easy, but suppose that the size of this class is so huge, like 5,000 people, 5,000 students. So how do I find out the mean height of my class? So one method is to choose one person randomly, okay? But do that many times. So whenever I choose one person, I ask his or her height. I just write it down, and then I put him back. I choose another person at random, ask his height. Put him back, okay? So by drawing a lot of people randomly, I can take a lot of heights of them, and I take the average. So long run means I do this many, many times, okay? That number approaches to this particular number. So in that sense, the mean is the long run average, value of the random variable, over many trials. Now what is the variance? Variance shows the spreadness, right? Okay, let's not do that. So if variance is big, it's spread out. So some people are really tall, some people are very short. If variance is small, then everybody just looks the same. Okay? So this is the mean and variance. What's important for us is how to calculate them. If there is a distribution, probable distribution is given. So this is one example. You have the same example in example 2. So can you try? Can you calculate the mean and variance? In example 2, if you don't have a copy, just solve this, okay? solve this question. Just apply that formula over there, the two formulas. So what is the mean of this random variable? 됐어요? 연필 가지고 해봐요. 이거요? 답이? 이렇게. So what's the answer for A? What's the mean? It's P. It's P. The probability of success. Did you get it?
Oh, sorry.
Now what's the variance? P times 1 minus P. Now what is the answer for C? P, okay? Okay, I just want to say one thing. So this is how you calculate the mean and variance. What actually matters for us is, so these are important. What is even more important is a conditional version of mean and conditional version of variance, right? That's something we are going to do the next week. Okay, so remember that you have those homework problems. Maybe these are reviews, so I'm pretty sure that you can start right now. And I'll see you in the next week.